it is difficult to steer a parked car, so get moving. Today, we will talk about the analysis of motions, or in physics we call this the mechanics. So this is the analysis of motion, and in mechanics has two branches. That is what we call the kinematics and the dynamics. So in kinematics, it's a branch of mechanics that deals with describing motions, and dynamics, a branch of mechanics that deals with explaining motions. So these are the two branches of mechanics. But today, we will only focus on the mechanics or kinematics part. So a branch of mechanics dealing with the description of motions or describing motions. So we will only focus on this part. And in analysis of motion or in describing motion in kinematics, in this topic today, I have divided kinematics into three parts. So if we compare these three parts into the Cartesian plane, so we can say that the first part, or the movement or motions on the first part, is along x-axis. So therefore, the movement is along horizontal axis. So their movement is horizontal. And the second part is along y-axis. So the movement is vertical, so either up or down. So those are the movements on the second part. And on the third part, we can say that it is the combination of the first and the second part, because it is the combination of the x and y axis. So I divided topic on kinematics into three parts so that it is much easier for us to understood the concepts on kinematics. But before that, first, let us have a little review on scalar and vector quantity. So when we say scalar, scalar is only a magnitude. It has no direction. So when we say vector, it is a combination of both magnitude and direction. Okay, so in kinematics or in mechanics, so in motions, we also have an example of both scalar and vector quantity. So what are these examples of scalar and vector quantity in motion? So these are the speed and velocity. Okay, so when we say speed, it is only the speed of an object without a particular direction. And velocity, so velocity is the speed of a particular object with a specific direction. So that is the reason why velocity is a vector quantity and speed is a scalar quantity. So the equations for speed and velocity is the same. So speed and velocity, they just differ in direction. Okay, so you can observe velocity has an arrow which indicates direction. So the equation is equal to delta D over delta T. So I think you are familiar with the symbol delta, this triangle. So you already discussed what is the meaning of delta during your basic calculus. So kung nakalimutan nyo na, then as a review, so delta means change. So if there is an increment or an increase or a decrease, So it means change. So therefore, delta D means change of distance over delta T, or the change of time. So these are this is the equation for both speed and velocity. So let us try to use this equation in a problem or in a situation. So a bus travels at 6.8 meter per second. What is the distance covered by the bus in 37 minutes? So as we can see, we have the speed given on the bus, which is 6.8 meter per second, and as well as the time, which is 37 minutes. So the question is, what is the distance covered by the bus during the 37 minutes of travels? So using the equation for speed, so we have speed is equal to the change of distance over the change of time. So substitute. So speed is 6.8 meter per second. The change of distance is still unknown. And then we have 37 minutes as the change of time. Okay, so before you proceed with your solution, okay, take note. Before proceeding to your solution, before you solve for your unknown, okay, make sure that the given or the unit of your givens are all the same. Okay, for example, in this case, speed is in meter per second. Okay, so the speed is in meter per second. And then the time given is in minute. Okay, so since they have different units, so we cannot proceed with our solution because they have different units. So, anong gagawin natin? So, we need to convert first either of the two, either 6.8 meter per second or 37 minutes. So, we convert 6.8 meter per second to meter per minute, or we convert 37 minutes to second. So, either of the two, it based on your discretion kung sino ang gusto mo na i-convert. Okay, so this time, since it is much easier for us to convert 37 minutes into second, so we will convert 37 minutes to seconds. So 37 minutes times 60 seconds divided by 1 minute is equal to 2,220 seconds. And then replace your converted time. Okay, so we have 6.8 meter per second is equal to the change of distance divided by your converted time, which is 2,220 seconds. Okay, next. After making sure that the units of your given are all the same, now we can proceed with our solution. Okay, first is we need to reconstruct or manipulate our equation. Okay, place the unknown on the left side and all the given on the right side. So the unknown or the delta D, we'll place it on the left side, and all the given is on the right side of your equal sign. Okay, next. So we will reconstruct this. So transpose. Okay. So we have delta D is equal to 6.8 meter per second times 2,220 second. Okay. So bakit natin why do we have to convert first our given so that they have the same unit? It is because you cannot cancel different units. So for example, if second and minute, so hindi pwede na i-cancel natin si second and si minute. So that is the reason why we need to convert first either of the two para magkapareho ang kanilang unit. So that we can cancel both second and second. So ang naiwan na lang ay si meters. So next, 6.8 times 2,220, that is equal to 15,096 meters. Okay, next. Since we have the value of our distance, okay, but according to the rule of the significant figures, okay, your answer should follow the least number of significant figures. So since the least number is 2 significant figure, so we will round our answer to 2 significant figures starting from the left. So we have 1, then 2. So we will round this up to 5. So from 15,096 rounded to 2 significant figure, that is equal to 15,000 meters. And so the distance covered by the bus in 37 minutes after traveling at 6.8 meters per second, so that is 15,000 meters. Okay, so that is how to solve distance using the equations of speed and velocity. So, sir, how about if si time na naman ang aming kukunin? Okay. So, what if time ang ating kukunin? So, the distance from San Pedro College to your home is 56 kilometers. Suppose the jeepney you ride every day travels at the speed limit of 60 kilometers per hour. So, how many minutes is your travel time? Okay, so, kanina, we solve for the distance. So, this time, we solve for the change of time in terms of minutes. Okay, so since specific question that the question is how many minutes, so specific siya na minutes dapat ang iyong time. So, we'll solve the time interval in terms of minutes. So, we have the distance, which is 56 kilometers, as well as the speed, which is 60 kilometers per hour. So, using the equation, okay, substitute. Okay, so after that, make sure that the units are the same. So, since they have the same kilometers, now we can proceed. Okay, so reconstruct your equation. So, transfer the unknown to the left side and all the given to the right side. So we have delta T is equal to 56 kilometer over 60 kilometer per hour. Okay, next, 56 divided by 60, that is equal to 0.93 hour. So, since the question is how many minutes is your travel time, okay, so since the question is how many minutes is your travel time, and the answer of our delta T is equal to 0.93 hour, okay, so since it is in hour, so first we need to convert this to minutes. But before that, okay, so paano ba natin nakuha si hour? So, para makuha si hour, so we have our numerator, which is in kilometers. Okay, so since the denominator is in fraction form, so we have kilometer per hour. According to the rule of fraction, the denominator should be reciprocate, or dapat we should reciprocate the denominator. So the reciprocal of kilometer per hour is hour per kilometer. So, from division, magiging multiplication. And then, cancel. So, that is the reason bakit siya naging hour. Okay? And then, after that, we'll convert 0.93 hour to minutes. So, 0.93 hour times 60 minutes per hour is equal to 55.999. Okay, this is not a second. This is in minute. Okay, so 55.999 minutes. So, cancel si hour. And so, ang naiwan na lang is minute. And since the least number of significant figure, so we have two significant figure, so we will convert 55.999, we will round this to two significant figures starting from the left. So we have 1, 2. So to round this from 55 will become 56 minutes. So that is how we solve the distance and time using the velocity or the speed equations. Okay, so speaking of velocity, so since we are talking about velocity, if there is a change in velocity, so therefore if there is an increase in velocity or there is a decrease in velocity, so therefore there is an acceleration acting on the object. Okay, so acceleration, if there is a change in velocity. So either nag-decrease ang kanyang velocity or nag-increase ang kanyang velocity, so there is an acceleration acting on the object. So a change in velocity, either there is a change in speed or there is a change in both speed and direction. So that is acceleration. And the equation for acceleration, since there is a change in velocity per unit time, so there is a final velocity and an initial velocity. So there is a final velocity and an initial velocity. So acceleration is equal to final velocity minus initial velocity divided by the change of time. Okay, the change of time is the time interval during the change in velocity. So if there is a change in velocity, so there is a final velocity, which is the velocity after, okay, final velocity is the velocity after acceleration happens, and initial velocity is the velocity before acceleration happens. So that is the final and initial velocity. And take note, if the final velocity is greater than the initial velocity, so therefore the acceleration is positive. Once the acceleration is positive, then the object or the speed or the velocity of the object is increasing. So there is an increase in velocity or the object is speeding up or nag-speed up ang object. But if the initial velocity is greater than the final velocity, then the acceleration is negative. So once the acceleration is negative, so therefore the speed or the velocity of the object is decreasing. So nag-slow down ang object. Okay? Remember, always remember that if acceleration is positive, then nag-speed up ang object. But if the acceleration is negative, then nag-slow down ang object. Okay? So, Let's have an example using the equations on acceleration. So, how long will it take to stop a bus moving at 6.8 meter per second with a constant acceleration of negative 3.6 meter per second square? Okay, so do not get confused with the velocity and acceleration. So though they have almost the same units, though they have almost the same units, but there is a difference between their units. And what is this difference? So in velocity or speed, the time or the change of time is in first degree. Or when we say first degree, the exponent of your time is only 1. Okay? So you can see 6.8 meter per second. So the exponent of seconds is only 1. While in acceleration, okay, in acceleration, the time on your acceleration or the exponent of your acceleration is 2. So it is in square. So for example, 3.6 meter per second square. So that is how to differentiate velocity and acceleration. So in this case, we have our acceleration, which is negative 3.6 meter per second. Then we also have our velocity, which is 6.8 meter per second. But the question is, what type of velocity is this? Is it the final or the initial velocity? Okay, so to be able to know if this is the final or the initial velocity, let us reread the question first. Okay, so how long will it take? Okay, how long will it take to stop the bus moving at 6.8 meter per second? So since it is moving at 6.8 meter per second, okay, so it is moving from 6.8 meter per second to stop. So therefore, the driver of the bus hits the brake. So para matigil ang bus. So before hitting the brake of the bus, the bus is moving at 6.8. So before nag-decrease, the velocity is 6.8. So therefore, since it is the velocity before, so therefore it is the initial velocity. But what is the final velocity? So after hitting the brake, okay, after hitting the brake, so after decreasing the velocity of the bus, ang nangyari sa bus is nag-stop siya, so huminto. So therefore, our final velocity, okay, our final velocity, so since nag-stop ang bus, so it is not moving. So if it is not moving, so therefore the velocity is now equal to 0. So therefore, the final velocity of the bus is now equal to 0. Okay, so the unknown this time is the time interval during the acceleration of the bus, or during that time that the driver is hitting the brake of the bus. So because the word how long will it take, so therefore we are looking for the change of time or the time interval as the bus decreases its velocity. So using the acceleration equation, so substitute, we have negative 3.6 is equal to 0, which is our final velocity, minus the initial, which is 6.8, divided by the change of time. Okay, so reconstruct your equation. So we have the change of time is equal to 0 minus 6.8 divided by 3.6. Okay, so 0 minus 8 is 3 negative 6.8. So 6.8 divided by 3.6, that is equal to 1.8888 seconds. And since the least number of significant figure we have is only 2 significant figure, so we will count 2 significant figure from the left. So we have 1, 2, and then we round this up to 2 significant figure, and that is equal to 1.9 seconds. So that is the acceleration equation. Okay. So if kanina we solve for the time interval, okay, so this time we'll use that time interval to be able to identify different unknown. Okay, so a man is riding a bicycle at a constant acceleration of negative 2.10. So since the acceleration is negative, so therefore nagbaba ang kanyang speed. So if it takes 4.2 seconds to stop, so since nag-stop, so therefore the final velocity is, because it needs 4.2 seconds to stop, so since from the word to stop, so the final velocity is still 0. So what is the speed before stepping on the brake? So speed before, so therefore we are looking for the initial velocity. Okay, we are looking for the initial velocity. So using the equation of acceleration, we have the final velocity minus the initial velocity divided by time. So substitute. Okay, so negative 2.10 is the acceleration. 0 is the final velocity minus the initial divided by the time interval, which is 4.2 seconds. Okay, so reconstruct. We have 0 minus initial is negative. So negative 2.10 times 4.2 seconds. So that is equal to negative 8.82 meter per second. But since our initial velocity is in negative, so we need to convert our initial velocity to positive first by multiplying negative 1 to both sides. So negative 1 times negative initial velocity, that is positive, and negative 8.82 times negative 1, that is positive 8.82. And after that, round your answer to the least number of significant figure, which is 2. So we have 1 and 2. So from 8.82, round to 2 significant figures. So we have 8.8 meter per second. And that is how to solve using acceleration equation. Okay, so kanina, I mentioned that the kinematics, so I divided kinematics into 3 parts. So the first part, so if we compare these parts into the Cartesian plane, so the first part is the movement is along x-axis. The second is along the y-axis, and the third part is along the combination of x and y axis. So the first part, those who are acting on the x-axis, so that is what we call the translational motions. So translational motions, so these are motions acting on the horizontal axis or on the x-axis. So translational motions are all vertical motions. So in translational motions, we have these three equations which we call the basic formulas. So we have these three equations in translational motion. Okay, first we have the velocity. Okay, so I think you may react that this is the equation for acceleration, but later I will discuss why is it called the velocity. Then the second equation, we have the time independent. And lastly, the third equation, we have the displacement equation. Okay, for equation 2, so based on its name itself, and as we can observe on the equations, so I think it is uh, easier for us to understand why is it called time independent. Okay, so as we can see on the equation, there is no time on the equation. So 2 times acceleration times distance is equal to final velocity minus the initial velocity square. So the time independent, so when we say time independent or the equation 2, it is, we will use this equation if there is a change in velocity and the time is not specified. So if it is not specific with the time interval, so the time is not specific. So when we say it is not specific, so therefore, hindi siya specified kung ano ba ang kanyang time interval. So therefore, we will use the time independent equation. Okay, for equation 1, so how about the equation 1 and equation 3? What is their difference? Okay, for equation 1, we will use equation 1, okay? It is called the velocity equation. Why is it called velocity? Because we will use equation 1 if there is only a change in velocity. Okay? So there is only a change in velocity without a specific distance. Okay? So there is a change in velocity without a specific distance between that time interval. So nag-change ang kanyang velocity given in a time interval, pero hindi naman specific kung ano ang distance na na-travel niya during that time interval. So that is equation 1. And how about equation 3? Okay, so equation 3, there is a change in velocity with an specific time, with a specific distance covered. Okay, so equation 3, so there is a change in velocity, either nag-speed up siya or nag-speed down siya in a given distance. So there is a change in velocity and specific rin ang kanyang distance na na-travel during the time interval. Okay, so that is the difference between equation 1, equation 2, and equation 3. So I repeat, equation 1, there is a change in velocity without distance covered during a time interval. And equation 2, there is a change in velocity without a specific time interval. And equation 3, there is a change in velocity with a specific distance during the time interval. So those are the difference between these three equations. Okay, so let's have an example with translational motion. Okay, so a car starting from rest accelerates uniformly at a rate of 4.9 meter per second square. So what is the car speed after the traveled after it traveled 200 meters? Okay, so as we can see, okay, so the unknown on this given or specific question, so this specific problem, the unknown is the car speed after. Okay, so once we say car speed after, so therefore we are referring with the final velocity. So we have the distance, which is 200 meters. We also have the acceleration. Okay, we have the acceleration. So we have the final velocity, which is the unknown. Okay, so since there is no specific time interval during the change of velocity, so therefore we will use equation 2 or the time interval. But in equation 2, we need the initial velocity. So what is the initial velocity? So since the car starts from rest, so since it starts from rest, so therefore the initial velocity of the car is equal to 0. Why 0? Because since it starts from rest, so hindi siya nag-move. So since it is not moving because it is from rest, so therefore the initial velocity is equal to 0. Okay, so we have our final velocity as unknown. The initial is 0. Acceleration is 4.9 meter per second square and the distance which is 200 meters. So since hindi specific ang kanyang time interval, okay, so since hindi specific ang kanyang time interval, so we will use the time independent equation. Okay, so applying time independent equation, so substitute. Acceleration is 4.9, the distance is 200, final velocity is unknown, and the initial is equal to 0. So 0 times 0, still 0. Okay, next. 2 times 4.9 meter per second square times 200 meters. So if we input this in our calculator, that is equal to 1,960 meters square over second square is equal to final velocity square. So since our final velocity is in square form, so since naka-square siya, so we will apply the square root on both sides para mawala ang square ng ating final velocity. So the square root of final velocity square, that is equal to final velocity. The square root of 1,960, that is equal to 44.2718. Square root of m squared, that is m. Square root of s squared, that is s. Okay, the next. So since in our given, we only have one significant figure as the least number, so we will round our answer to one significant figure from the left. So we have 1. So round to one significant figure, and that is equal to 40 meter per second. And so the car speed after traveling 200 meters starting from rest with an acceleration of 4.9 meter per second is equal to 40 meter per second. Okay, so that is how we use the time independent formula or the equation 2. Okay, next. Let us try a different example for different and use different type of equation. or different formula. Okay, so a car traveling on a straight road at 15 meter per second then accelerates uniformly to a speed of 21 meter per second in 12 seconds. So find the total distance traveled by the car in this 12-second time interval. Okay, so the question is the total distance. So what is the distance covered by the car? Okay, this time, okay, unlike kanina, there is no specific time interval given. So this time, there is a 12-second time interval given. So therefore, we cannot use the time-independent formula. So since we are looking for the distance, so we will use equation 3 or the displacement formula. Okay, next is to identify the unknown. So next is to identify the given. So we have 12 seconds as our change of time. Then we have 15 minutes per second, 15 meters per second as our velocity, and 21 meter per second as the other velocity. But the question is, which among these two is the initial and which is the final? So if the car is traveling at a straight road at 15 meters per second, so this is the speed of the car before accelerating to a speed of 21 meters. So since this is the velocity before, so this is the initial velocity. And 21 meters per second is the velocity after acceleration. So this is our final velocity. But the question is, what is the acceleration of this given problem? So since hindi ibinigay ang ating acceleration, so still unknown din ang ating acceleration. In using the equation 3, which is the displacement formula, we need the acceleration to be able to solve for the displacement of our object. But since we do not have the value of acceleration, first is we need to solve for the value of our acceleration using equation 1. So using equation 1, we will solve for the value of our acceleration. So first, let us solve for acceleration. So Vf, or the final velocity, is 21 meter per second minus the initial, which is 15 meter per second. And then divided by the change in time, which is 12 seconds. So 21 minus 15, that is 6 meter per second, divided by 12 seconds, so that is equal to 0.50 meter per second square. So since we have now the value of our acceleration, then we can now use equation 3 and solve for its distance. Okay, so d is equal to initial times time plus 1/2 of the square of time times acceleration. Okay, so substitute. So 12 seconds times 12 seconds, then that is equal to 144 second square. So if we input this in our calculator, so 15 times 12 plus 1/2 times 0.50 times 444, so that is equal to 216. Sir, bakit siya naging meters? Okay, so 15 meter per second times 12 seconds, so we can cancel seconds. Then 1/2 times 0.50 meter per second squared times 144 second squared, so we can cancel second square. So naiwan na lang is C, meters. So meters plus meters, that is equal to 216 16 meters. And since the least number of significant figure in our given, it only has two significant figures, so we will round our answer to two significant figure starting from the left. So we have 1, 2. So round to two significant figure, that is equal to 220 meters. Okay, so for the second part of the kinematics, okay, as mentioned kanina, the second part or the movement of objects in the second part of kinematics is along y-axis. So the movement is either up or down. So the movement is only vertical. So that is what we call the free fall motions. So in free fall motion, we also have equations to be used, but don't worry, because the equations to be used in the free fall motion is almost the same with the translational motion. If this is the this is the equations of translational motion. Okay, if we can still remember, this is the equation of translational motions, the first part. Okay, as I have said, it is almost the same with the equations on translational motion, because the only difference between translational and free fall motion is that the acceleration on free fall motion is already given. Okay, so the acceleration on free fall motion is already given. So what is the acceleration on free fall motion, sir? Paano namin malalaman ang acceleration on free fall motion? Okay, so the acceleration on free fall motion is the acceleration due to gravity. So since the movement of your object is either up or down, so it is pulled, so therefore it is pulled by the gravity. So that is the reason why the acceleration is substituted by the acceleration due to gravity, because the object is being pulled by the gravity, which has a value of 9.81 meter per second square. Sir, bakit siya positive, negative? Ano bang gagamitin namin? Positive or negative? Okay. So, if the movement of your object is downward, so since the gravity is pulling the object downward, so therefore if the movement of your object is downward, so therefore we will use a positive gravity. And if the movement of your object is upward, so if it is upward, since we are contradicting the gravity, so since contrast sa gravity, so therefore we will use the negative gravity. Okay, so negative gravity if it is upward and positive gravity if it is downward. So substitute acceleration due to gravity, which is a symbol of G, to our acceleration, which is a symbol of A. So the formula for free fall motion. So these are the formula for free fall motion. They just differ in acceleration due to gravity. But the concept is the same. They have the same concept on equation 1, equation 2, and equation 3. So that is the only difference, the acceleration due to gravity. So let's have an example. Okay, so a rock is dropped from the top of a building the sound is heard after 4.2 seconds. So what is the height of the building? So speaking of the height of the building, so therefore, we are looking for the displacement of the rock since it is dropped from the top. Okay, so since it is dropped from the top, then it hits the bottom of the or the ground after 4.2 seconds. So this is our change in time. So since we are looking for the height, so we are looking for the distance or the displacement of the rock starting from the top. So next, okay, so since we also have the value of our acceleration, which is the acceleration due to gravity, and our time, which is 4.2 seconds. Okay, so how about the velocity of the rock? So do we have a value of velocity? Okay, so since it is dropped from the top of a building, so before you drop the rock, so you are holding the rock while you are at the top of the building. Okay, so if you are holding the rock, so therefore there is no movement on that rock. So since there is no movement, so therefore that is the velocity, which is equal to 0. But what type of velocity? Is it the initial or the final? So since it is the velocity before you drop, so therefore it is the initial velocity. So we have our initial, which is 0, the gravity, which is 9.81, the distance, which is unknown, 4.2 seconds, which is our time, and the final velocity, which is also unknown. So using this given in concept, so since we are looking for the distance or the displacement, and we have the time given, so we will use the displacement formula. So using displacement formula, okay, applying displacement, so D is equal to VI times T plus 1/2 GT square. So substitute. So VI is 0 plus time plus 1/2 of gravity times time square. So 0 times 4.2, that is equal to 0. Okay. So if we input this in our calculator, so 1/2 times 9.81 times 4.2 square, so that is equal to 86.52 and 42 meters. So if we round this to two significant figures, so we have 1 and 2, so 86.5242 rounded to two significant figure, that is equal to 87 meters. So therefore, the distance or the height of the building is equal to 87 meters. Okay? Okay, a ball is dropped from a 15-meter building. So what is the velocity of the ball at the moment it hits the ground? So we are looking for the velocity of the ball as it hits the ground. So since this is a ball is dropped from a 15-meter building, so we have our distance. So the distance is 15 meter. Okay, so since it is dropped from the top, okay, same with the rock kanina. So since you are holding the ball while you are at the top of the building, so you are, therefore the velocity is 0. And since it is the velocity before you drop, so it is the initial velocity. Okay, if we have our initial velocity, so since this is the velocity of the ball after it was released from the top of the building, so therefore it is our final velocity. So the question is, what is the final velocity of this ball? Okay, so final velocity, the initial is 0. We have our gravity and the distance, and the time is unknown, so it is not specific. So the time is not specified. So since the time is not specified, so we will use the time independent formula. Applying time independent. Okay, so substitute. The gravity is 9.81 times the distance, which is 15 meter. Final velocity is unknown, and the initial is 0. Okay, so 2 times 9.81 times 15, that is 293.3 meters square over second square. So since our final velocity is in square, so we will we will apply square root on both sides. So square root of BF square is equal to the square root of 294.3 meters square second square. So applying square root, the answer is the final velocity is 17.1551 and so on meter per second. And since the least number of significant figure is 2, so we will round this up to 2 significant figures starting from the left. So we have 1, 2. So from 17.1551, round to 2 significant figure, and that is equal to 17 meters per second. An astronaut standing on the platform on the moon drops a hammer. So if the hammer falls 6 meters vertically in 2.7 seconds, what is its acceleration? So since it drops the hammer, so it is on the, or it falls on the free fall motions. But since the astronaut is on the moon, so therefore the acceleration or the gravity on the moon is different on the gravity on the earth. So we will solve for the gravity of the so we will solve for the acceleration due to gravity as the astronaut drops the hammer at 6 meters vertically within 2.7 time interval. Okay, so since we have distance and a time interval given, so we will use the equation 3. So since it has a time interval and a distance covered during that time interval, so we will use the equation 3. So question is, what is our velocity? Okay, so nasan na dito ang ating mga velocity? So since the astronaut drops the hammer, so before dropping the hammer, he is holding the hammer, and that is our initial velocity. So before he drops the hammer, he is holding the hammer, and the initial velocity is equal to 0. So the final velocity is unknown. The initial velocity is equal to 0. The gravity of the moon or the acceleration is also unknown. And the distance is 6 meters. And the time interval is 2.7 seconds. So since we have a distance covered during a time interval given, so we will use the displacement formula. So applying displacement, so substitute, distance is 6 meters, the initial is 0, time interval is 2.7 plus 1/2 of the gravity of the moon, which is unknown, times the square of the time, which is 2.7 seconds square, so 0, Okay, so 1/2 of 2.7 squared, that is 3.645 seconds squared. So divide both sides by 3.645. So that is equal to 6 meter over 3.645. So if we divide this, the answer is 1.64609 and so on. And since we have one significant figure, we will round this to one significant figure starting from the left, and that is equal to 2 meter per second square. Okay, so that is the gravity of the moon, or the acceleration of the hammer as the astronaut